Good morning, friends. Today we will start Asme Section 8 Division 1, Subsection C, requirement pertaining to classes of material. Part UCS, requirement for pressure vessel construction constructed of carbon and low alloy steels. General UCS 1 scope. The rules in Part UCS are applicable to pressure vessels and vessel parts that are constructed on the carbon and low alloy steels that shall be used in conjunction with general requirement in subsection A and with the specific requirement of subsection B that pertain to the method of fabrication used. Materials, carbon and low alloy steels. The specification maximum composition limits or certificate values for the backing strip material shall not exceed those of material specification for pressure part in which attached. Backing strip base metal and the associated heights and the weld metal shall be impact tested in accordance with UG 84. The MDMT is shown on the nameplate with the butt weld test specimen to be pressure part material or a material with same P number and group number as pressure part. The backing strip material specification minimum percentage elongation shall be at least equal to that of the pressure part material specification. Carbon or low alloy steel having carbon content of more than 0.35% by heat analysis shall not be used in welded construction or be shaped by oxygen coating except as provided in Part UF in this division. Small parts used under the provision of UG 11 A2 in the welded construction shall be good weldable quality. So UCS 23 carbon and low alloy steels different materials specifications. You can see here what are the specifications, type and grade. Ellipsoidal, toruspherical, hemispherical and conical heads having pressure on the convex side. Minus heads shall be designed by rules of UG 33 using the applicable figures in section 2 part D subpara 3. Shall be designed by rules this. UG 33. Using the applicable figures in section 2 part D subpara 3. Okay. A requirement for post-weld heat treatment. Before applying the detailed requirement and exemption for this paragraph, satisfactory weld procedure qualification of the procedure to be used shall be performed in accordance with all essential variables of section 9, including condition of post-weld heat treatment or lack of post-weld heat treatment, including other restrictions listed below, except otherwise specifically provided in the notes to table UCS 56 through UCS 5611. In table UCS 56.1, all welds in the pressure vessel or pressure vessel parts shall be given a post-weld retreatment at a temperature not less than specified in these tables when a nominal thickness as defined by UW40F, including corrosion allowance, exceeds the limit of those tables. The exemptions provided in table UCS 56-1 through UCS 11 or table UCS 56.1 are not permitted when the post-weld retreatment is a service requirement as set forth in UCS 68. When welding ferrite materials greater than 1/8 inch 3 mm thick with the electron beam welding process, or when welding P number 3, P number 4, P number 5A, 5B, 5C, 10 and P number 15 materials of any thickness using the inertia and continuous dry friction welding process. Electroshock welds in ferritic materials above 1/2 inch 38 mm thickness at the joints shall be given a grain refining, oxidizing heat treatment. Electro gas welds ferritic material with any single pass greater than 1/2 inch 38 mm shall be given a grain refining, oxidizing treatment for P number 1 materials only. The heating and cooling rate restriction of D2 and D5 below do not apply when the heat treatment following welding is austenitizing range. When pressure parts of two different P number groups are joined by welding engineering judgment, shall be applied when selecting post-weld heat treatment temperature and holding time to produce material properties suitable to the intended service alternatives such as welding with buttering as described in section 9. QW283 may be considered when non-pressure parts are welded to pressure parts. The post-weld heat treatment temperature of the pressure part shall control. The operation of post-weld heat treatment shall be carried out by one of the procedures given in UW40 in accordance with the following requirements. The temperature of the furnace shall not exceed 800 degrees Fahrenheit, 420 degrees Fahrenheit centigrade, the time of vessel or part placed in it. Above 800 degrees Fahrenheit, 425 degrees centigrade, the rate of heating shall not be more than 400 degrees Fahrenheit per hour, 222 degrees centigrade per hour, divided by the maximum metal thickness of the shell or head plate in inches, but in no case more than 400 degrees Fahrenheit per hour, 22 degrees centigrade per hour. During the heating period, there shall not be greater variation of temperature throughout the portion of the vessel being heated than 250 degrees Fahrenheit, 140 degrees centigrade within an 15 foot 4.6 meter interval. The vessel or vessel part shall be held at or above the temperature specified in table UCS 56 through UCS 56-11 and UCS 56-1 for the period of time specified in table. During holding period, there shall not be a greater difference than 150 degrees Fahrenheit, 83 degrees centigrade between highest and lowest temperature throughout the portion of the vessel being heated, except where the range is further limited in USS 56-1, 56-11. During the heating holding period, the furnace atmosphere shall be controlled to avoid excessive oxidation of the surface on the vessel. The furnace shall be such designed to prevent direct impingement of the flame on the vessel. So above 800 degrees Fahrenheit, 420 degrees centigrade, cooling rate shall be done in a closed furnace cooling chamber at a rate not greater than 500 degrees Fahrenheit per hour, that is 280 degrees centigrade per hour, divided by maximum metal thickness of the cell or head plate in the inches, but in no case more than 500 degrees centigrade Fahrenheit, 500 degrees Fahrenheit per hour or 280 degrees centigrade per hour at temperature above 800 degrees Fahrenheit, 425 degrees centigrade. Temperature variation within the heated portion during the cooling phase shall not greater than 250 degrees Fahrenheit, 150 degrees per second within any 15-foot 4.6 meter interval from 800 degrees Fahrenheit. Okay, from 800 degrees 425 degrees centigrade, the vessel may be cooled in still air, except as permitted in F below. Vessel or part of vessel that has been post-weld treated in accordance with the requirement of the paragraph shall again be post-weld heat treated after weld repairs have been made. Weld repairs to P number 1, group number 1, 2, 3 materials, and P number 3, group number 1, 2, 3 materials, and the weld metals used to join these materials may be made after the final PWST, but prior to final hydrostatic test without additional PWST, provided the PWST is not required as a service requirement in accordance with UW2A, except for the exemption in table 56.1 through UCS 56.11, or as a service requirement in accordance with UCS 68. The welded repairs shall meet the requirement of 1 through 6 below. The requirement do not apply when the welded repairs are minor restoration of material surface, such as those required for removal of construction fixtures, and provides that the surface is not exposed to vessel content. The manufacturer shall give prior notification of repairs to users or its designated agent, and shall not proceed until acceptance has been obtained. Such repairs shall be recorded in the data report. The total repair depth shall not exceed 1.5 inch, 38 mm for P1, group number 1, 2, 3 material, and 16 mm for P3, group number 1, 2, 3 materials. The total depth of weld repair shall be taken as a sum of depth repair made from the both sides of weld at the given location. In addition to the requirement of section 9 of the qualification of welding procedure specification for groove welds, the following requirements shall apply. The weld metal shall be deposited by manual shielded metal arc process using low hydrogen electrodes. For P number 1, group number 1, 2, 3 materials, the repair area shall be preheated and maintained at a minimum temperature of 200 degrees centigrade, 95 degrees centigrade during welding. P number 3, group number 1, 2, 3 materials, the repair weld method shall be limited to half bead weld repair and weld temper bead reinforcement technique. The repair area shall be preheated and maintained at minimum of 350 degrees Fahrenheit during the welding. The maximum interpass temperature 450 degrees Fahrenheit to 30 degrees centigrade. The minimum temperature 350 and interpass temperature 450 degrees Fahrenheit. The initial layer of the weld metal shall be deposited over entire area using 1/83 maximum diameter electrode. Approximately 1/2 of the thickness of the layer shall be removed by grinding before depositing subsequent layer. The subsequent weld layer shall be deposited using 5/32 inch 4 mm maximum diameter electrodes in such a manner that is to assure tempering of the prior weld bits and their heat affected zones. After completing all welding, the repair area shall be maintained at temperature of 400 degrees Fahrenheit to 500 degrees Fahrenheit, 205 degrees to 260 degrees centigrade for a minimum period of 4 hours. The final temper bead reinforcement layer shall be removed substantially flush with the surface of base metal. The examine is by magnetic particle method only. Okay, there is another thing is there. For P number 3, group number 3 material, the examination shall be made after the material has been ambient temperature for 48 hours to determine the presence of possible delayed cracking of the weld. The examination by the magnetic particle method only alternating current yoke type is acceptable. In addition, welded repairs greater than 3/8 inch 10 milli depth in material and the welds that are required to be radiographed by the rules of division shall be radiographically examined to the requirement of UW 51. The vessel shall be hydrostatically tested after making the welded repair. Capacitor discharge or electric resistance welding may be used for attaching bar wire thermocouples. A welding procedure specification shall be prepared and content shall be described as a minimum. The capacitor discharge equipment, the combination of the material to be joined, and the technique of the application. Qualification of welding procedure is not required. Now there are tables. Table UCS 56 for P number 1, grade number 1 to 3, normal holding 1100 degrees centigrade. Minimum holding time 1 hour per inch, 15 minutes minimum, 2 hour plus 15 minutes additional inch over this continues. Same thing. When it is impractical to post-weld heat treated at the temperature specified in this table, it is permissible to carry out post-weld heat treatment at lower temperature for longer periods of time in accordance with table UCS 56-1. Post-weld heat treatment is mandatory under the following condition: for welded joints above 38 mm nominal thickness, the welded joint above 32 mm nominal thickness through 38 mm nominal thickness unless preheat is applied at a minimum temperature of 200 degrees Fahrenheit during the welding. The preheat need not be applied as said for 841 grade A and B, provided that the carbon content and carbon equivalent for the plate material by heat analysis do not exceed 0.14 inch, 14% and 0.4% respectively, where this is Ce carbon equivalent is carbon plus manganese by 6, chrome molyvalent M by 5, copper moly, copper nickel, copper nickel divided by 15. So then come UCS 56 to P number 3, grade number 1 to 3, 1100, same, this all same. When it is impractical to post-weld heat at the temperature specified in the table, it is permissible to carry out the post-weld heat treatment at lower temperature for longer period of time in accordance with table UCS 56-1. Post-weld heat treatment is mandatory on P number 3, grade number 3 material in all thickness. UCS 56.3 for this 1100 up to now it is increased to 1200. P number 4, 1, 2, and this thing is not there. When it is impractical to post-weld heat treat, this phrase is not there. So this is finished. 1 hour per inch, 15 minutes minimum, and here it is changed 1 hour per inch. So up to 5 inch it is go for 1 hour more for each inch. Here 15 minutes only. So that is the difference for P4. Then if you go to P5, 5A, 5B, grade number 1, and 5C grade number 1, you have 1250. So instead of this become 1200, from it increases 1250 then. So these two as before, and so after 1 hour you have to go for up to 5 hour plus 15. Here P9A, it is decreased now. If you see, it is 1250, but here 1100, 595. So 59A, 1 hour minimum plus 15 minutes per inch. So it is changed again. P9B remains same, P9A, P9B remaining about same. P10A, 10A is 1100 degrees centigrade, same, but 1 hour minimum plus 15 minutes for thickness over 1 inch. Same. P number 10C, it is decreased again, 1000 degrees centigrade Fahrenheit, 1 hour minimum plus 15 minutes per inch. (15E). Here it is changed again. It is increased to 1300 degrees centigrade. And note 3, note 4 they put. There are some restrictions here for temperature. And 1 hours per inch, but minimum is 30 minutes. Their minimum is 15 minutes, but here minimum is 30 minutes, 5 hour plus 15 minutes, so anything. Same thing, only this changes. 4 welds made with matching grade 91 filler metal AWS 5.5, 90XX B91, ISO EN chrome moly 91. The maximum holding temperature shall be determined as follows. If the nickel plus manganese content of the filler metal is less than 1% of maximum BWST, 1%, then the maximum BWST temperature shall be 1455 degrees Fahrenheit. So instead of this, you go for 1455. And note 1, 2, if the nominal thickness is, you have to even see this also. If the nominal weld thickness is less than 0.5 inch, 13 mm, the minimum holding temperature is 1250 degrees Fahrenheit. So instead of this, it is decreasing. The dissimilar metal welds, the welds made with P number 15E group number 1 and another lower chrome ferritic austenitic and nickel steel. If filler metal chromium content is less than 3, or if the filler metal nickel base austenitic and minimum holding temperature shall be 1300 Fahrenheit, 1300 degrees Fahrenheit. So if it is less than 3% chromium, that is this too for here minimum holding temperature, but maximum holding temperature, that is changing here. For 3, 4. If nickel chrome content of the filler metal is greater than 1% but less than 1.2, the maximum BWST temperature shall be 1435. Here 1455, here 1435. Okay. If the nickel chrome content, nickel manganese content of the filler metal is greater than 1.2%, the maximum BWS temperature shall be here at least 20 degrees Fahrenheit below the lower critical transformation temperature AC1 as determined by measurement of that temperature for specific heat. The heats of filler material to be used in accordance with ASTM A1033. In such case, the following additional restrictions will apply. The SU1 temperature of filler metal measured in accordance with the STM 1033 shall be included in the manufacturer's construction record. The maximum operating temperature of any vessel constructed using filler metal with nickel manganese content in excess of 1.2% shall be 975 525 degrees centigrade. The lower transformation temperature of the matching filler metal is affected by alloy content, primarily the total nickel manganese. The maximum holding temperature has been set to avoid heat treatment in the intercritical zone. If multiple welds are made with matching grade 91 filler metal in a pressure part and pressure vessel are to be post-weld heat treated at the same time, the maximum BWST temperature shall be determined based on the welds with highest nickel manganese content. If a portion of component is heated above the heat treatment temperature allowed above, one of the following actions shall be performed. The component on its entirely must be renormalized and tempered. The first thing, the maximum holding temperature in 3B above is exceeded but doesn't exceed 1470 degrees Fahrenheit, 800 degrees centigrade. The weld shall be removed and replaced. The portion of component heated above 1470 degrees centigrade, 800 degrees and 1470 degrees Fahrenheit, 800 degrees centigrade, and at least 3 inch 75 mm on either side of the overheated zone must be removed and been renormalized and tempered and replaced. The allowable stress shall be that of grade 9 material, SA 213T9, SA 335P9 or equivalent product specification at the design temperature, provided the portion of component heated to a temperature greater than that allowed above reheated within the temperature range specified above. To apply the provision of this paragraph, the manufacturer shall have qualified WPS with representative test specimen that accurately simulate the thermal history of the production part. Specifically, the qualification specimen shall first be heat treated at similar temperature for a similar time that violates the minimum holding temperature limit and shall receive a final heat treatment for the required time within the temperature range specified by this table. The use of this provision shall be noted in the manufacturer's datasheet. Alternative post-weld heat treatment, that is only P number 1 and 3, I think that is as per that only. But here those lower post-weld heat treatment temperature permitted only for P1, 2 materials. But still there is, if you go below the minimum specified temperature for any region, the minimum holding time will increase. Then radiographic examination. In addition to the requirement of UW11, the complete radiographic examination is required for each weld but welded joint at which thinner of the plate or vessel wall thickness at welded joints exceeds the thickness limit above the which full radiography is requirement in table UCS 57. So if you have P1 1 inch above, you have to go for 100% radiography. 32 and 3, you have to go for 19. 19 mm above, The same 10A, 10A and 3, same. So then 4 and 9A, 9B and 10B, 10C. All are 16 mm, 5 by 8. Then 5A, 5B, 5C, 15E, there is no limitation. There is anyway you have to do 100% RT as per code. So UCS 66, you have to go for impact testing and all. So let us see another thing. Let me show you. Carbon and low alloy steel having a carbon content more than 0.35% by heat analysis shall not be used in welded construction or be shaped by oxygen coating. Ellipsoidal, toruspherical, hemispherical and conical heads having pressure on the convex side minus heads shall be designed by the rules. When using different P numbers shall be used in higher temperature. Furnace temperatures should not be above 800 degrees Fahrenheit, 425 degrees centigrade. Rate of heating shall not exceed 400 degrees Fahrenheit per hour, 220 degrees centigrade per hour. Rate of cooling shall not exceed 500 degrees Fahrenheit per hour, 280 degrees centigrade per hour. Temperature range difference should not be above 150 degrees centigrade, 150 degrees Fahrenheit, 83 degrees centigrade. The total repair depth shall not exceed 1/4, 1 inch, 1 1/2 inch, 38 mm for P number 1, group number 1, 2, 3 materials, 5 by 8 inch, 16 mm for P3, group number 1, 2, 3 materials. Holding temperature and holding time shall be calculated from table UCS 56.1 to UCS 56.11. Table UCS 56.1 to alternative post-weld treatment requirement for carbon and low alloy steels. Table UCS 57 for thickness above which full radiographic examination of butt welded joints is mandatory. UCS 66. UCS 66 used to detect impact test required or not required. When using this code should be needed at 3 data: MOC, material of construction, T, the material thickness, MD, the minimum design material temperature. So the next we have to go for this UCS 66. We'll stop here.